Hello students, we are discussing electric field, and during that discussion one important concept discussed in between, what is solid angle and what is the use of this solid angle. Then the idea of electric field to be further extended. For that, two or three different points I want to discuss first, then I want to proceed further. The first thing we should know here, after we know the basic idea of electric field, what is electric field lines? Right, the definition: electric field lines or electric field lines or electric lines of force. Electric field lines or electric lines of force. Okay, let me explain what is that. Let me give you one example. Say this is one say positively charged object. Because of that, in the nearby region definitely there is electric field. We know this one already. If you consider any unit positive charge here, why unit positive charge? Because to measure direction of field and value of the field, by definition we need one coulomb charge. That 1 coulomb charge, because of this charge, gets a repulsion like this. If nothing in the surrounding, it will go in a straight line like this. Clear? If you release that same 1 coulomb here, it will go in this direction. So if you consider the same 1 coulomb release here, it will go in a straight line like this. If you consider same 1 coulomb here, it will be going in this side. So it is the direction along which a unit positive charge tends to move in this region where electric field present. By chance the charge considered is not positive, say negative, clear? Instead of going away, it will come towards the charge, clear? If a single charge present and nothing in the surrounding, then the lines will be always straight. But by chance, a case of two charges, say for example here one positive charge present and here one negative charge present. If you consider any 1 coulomb here released from rest, clear? I am discussing a different situation. First situation is understood. So because of this positive charge, 1 coulomb wants to go in a direction like this, but this negative charge will attract. So instead of going in a line like this, it will go in a curved line like this. Similarly, if that 1 coulomb starts from here, because of the repulsion it wants to go in a direction like this, but while going in this side, the negative charge will attract, so automatically the charge will go in a curved line. So what we are discussing, clear? Electric field lines. So you write the definition first, right? Electric lines of force or electric field lines are the lines along which a unit positive charge tends to move. A unit positive charge tends to move if it is free to do so in an electric field. Meaning, if you consider one electric field, a unit positive charge present, that unit positive charge will move in certain direction in a line. So that particular line is represented by electric field lines. Then one point I want to mention, you write separately: electric field lines may be straight line or may be curve. Electric field lines may be straight line or may be curve. The tangent drawn at any point, on a line of force, gives us the direction of electric field, at that point. Let me explain. If you consider a point here, if you draw a tangent, clear, it will be in that line, so no confusion. But there is a confusion in that curved line, because at this point it shows a direction like this, at this point it shows a direction like this, at this point it shows a direction like this, at this point it shows a direction like this. So that is why written tangent drawn, clear, at the point where you want to calculate field, clear, tangent drawn on the line gives us direction of electric field lines or direction of electric field at this point. Okay, once you know electric field, few important point from that concept of electric field. First of all, how to draw electric field lines. Say if you consider a positive charge, only positive charge, isolated, nothing else, the electric lines of force will be like this. So one thing clear, electric lines of force comes out from positive charge. If you consider a negative charge, clear, if you consider any 1 coulomb charge, it will be attracted towards it. So if you consider a negative charge, electric lines of force will be terminating on the negative charge. So you can say whatever electric lines of force, it originates from a positive charge and terminates on a negative charge. Terminates meaning coming to an end. This is one isolated positive charge, meaning this charge alone, and this is one isolated negative charge, meaning this charge alone. Now let me consider a combination of two positive charges. Here one positive and one negative considered. If one positive and one negative considered, from the positive it comes out, from at the negative it comes to an end. So drawing will be like this. If this is one positive charge and this is one negative charge, they are placed at a finite distance, then any 1 coulomb here will directly go to this point. Any 1 coulomb starting from this point, instead of going in this side, it will go like this. So it will go like this. Here lines of force because of the negative charge will be like this. Here lines of force because of the positive charge will be like this. Any lines of force going in this side will go to the negative charge. So a combination of positive and negative charges like this. I have no difficulty in that. If you consider two positive charges, say for example one positive charge is here and one other positive charge is here. Now it is quite interesting. If you consider any 1 coulomb here, that 1 coulomb wants to go in a direction like this. So while going in this side, this one will repel, so it cannot go in a straight line, it will go away from it like this. Similarly, if a line of force comes out from this one, yeah, instead of going in this side, because this is repelling, it will go like this. So now I want to discuss a point, whether they will intersect or not. Clear? Now their intersection is not allowed. Why? Let me explain. Clear? This is very important property. If you consider two lines of force intersecting, then at the point of intersection, we have the option of drawing two straight lines. Two tangents, sorry. As they are intersecting at the point of intersection, we have the option of drawing two tangents. Two tangent meaning there is two field present, one field in this side, one field in this side. Now look at a point only one field present. Why one field? Say for example these two charges present. Clear? Or say these two charges present. Clear? If you consider at a point here, of course there is a field because of positive charge and this positive charge in this side, and there is a field because of this positive charge in that side. So they will be in different direction. Clear? There may be 3 or 4 charges. Resultant we can measure. So resultant will be a single one. Two resultant not allowed. It is not that any 1 coulomb here goes in this side as well goes in this side. If this is getter goes towards right, if this is getter goes towards left, if they are equal, there is no field. But at a particular point only one field is allowed. Clear? So that is why direction of lines of force while drawing, it should be always take into account that their intersection is not allowed, because intersection of lines of force means at the point of intersection there is more than one direction of electric field, clear, which is not allowed. So one important property coming out here. So property is this, clear, you have to note it down, right? Properties of electric lines of force. Number 1, electric lines of force starts from a positive charge, meaning originates from a positive charge, and it terminates on a negative charge. And it terminates on a negative charge. Terminates meaning coming to an end. Number 2, intersection of lines of force, intersection of electric lines of force is not allowed. Is not allowed, as at the point of intersection, there are more than one direction of electric field. which is not allowed. At a particular point, there should be only one field. As I said, one field meaning that resultant field. 3 or 4 surges possible, 100 surges possible, but at a particular point, only the resultant field will be there. So because of the resultant field, it will move. It cannot move in all direction. It will move in the direction of resultant. Clear? So these two property discussed. One other property will be there. Before that, let me finish this drawing. Because of this positive surge, lines of force, if you draw, the extreme right and extreme left part will be like this. Here also a lines of force from here will go like this. A lines of force from here will go like this. In this middle region, there will be a point where electric field, because of this first one, and electric field because of the second one cancelling each other, there is no field. So lines of force in that middle region where electric field comes out 0, no need to draw. Otherwise, lines of force to be drawn like this. Clear? So how to draw electric field lines for a single positive surge, a single negative surge, a combination of positive negative surge, or two positive surge also discuss. Depending on their value, say by chance these two equal, result of 0 field will be exactly at the middle. By chance this is bigger, this is smaller, 0 field will be towards the smaller one. By chance this is bigger, this is smaller, resultant should be in this side. So resultant 0 will be in this side. So where 0, how to find? Already we know this point. Okay, let me use this electric lines of force for one other point. If you look at electric lines of force, we are discussing electric lines of force. So because of a surge here, I am drawing electric lines of force like this. Electric field, if you write, because of a point charge, we know q by 4 pi epsilon naught r square. Meaning as you go to greater distance, field goes on. As you go to greater distance, field goes on decreasing. So field goes on decreasing with distance. We can also get this idea with one other point. Clear? That point I want to discuss. If you consider a particular area here, say I am going to consider one area here. Yeah, I am considering one imaginary area here. Through this area, in this case, these 3 lines of force passing. If you consider the same area somewhere here, same area, then more number of lines of force passing through it. Clear? So one thing coming clearly, clear, number of lines of force passing per unit area or density of electric lines of force is somehow dependent on the strength of the field. Clear? Here, through this area only 3 lines of force passing. If you bring this area closer, the same area, then more number of lines of force passing through it. If you bring it even closer, even more number of lines passing through it. So closer the surge, density of lines of force more, and as you go away from the surge, density of lines of force becomes less. So third point of electric lines of force, please note the third point, right? The density of electric lines of force or field lines, the density of electric lines of force or field lines, the density of electric lines of force or field lines, that is number of lines of force per unit area, that is number of lines of force per unit area gives the strength of the field, gives the strength of the field. Meaning greater density shows greater field, lesser density shows lesser field. Okay, this is the basic concept of electric lines of force or electric field lines. Based on that, once in competitive exam one question appeared, just let me put the question here. Okay, write the question. Figure shows 2 point charges. Figure shows 2 point charges with their lines of force. Figure shows 2 point charges with their lines of force. Figure shows 2 point charges with their lines of force. Identify the region. Identify the region. Identify the region where electric field due to them identify the region where electric field due to them is zero. Identify the region where electric field due to them is zero. Okay, this is the question. Look at, this is region 1, this is region 2, this is region 3. First of all, only lines of force given and no other information. Now we can do. Look at this charge Q1, look at this charge Q2. We know electric field is given by this relation, Q by 4 pi epsilon naught R square. So if you consider a particular distance, I am considering a particular fixed distance here and the same fixed distance here. If you consider same area here and same area here, here density is more, here density is less. Yeah, I am keeping distance same. Here less density meaning lesser field, here more density meaning greater field. But we know field is dependent on charge. So one thing sure, Q2 value is greater than value of Q1. Why? Because Q2 at the same distance producing greater field. Greater field meaning greater charge because distance is same. Okay. I hope this is clear. Then here lines of force entering meaning Q1 is negatively charged and Q2 is positively charged. Clear? So these two information coming clearly. This is negative charge, this is positive charge, and value of Q2 greater than value of Q1. Why? Because at some distance, I am considering the same distance, we calculate density of lines of force. Here greater density, here lesser density. Clear? Meaning here lesser field. But we know field depends on distance. We keep distance same. So distance same, still lesser field, meaning charge should be less. Okay. Now where 0? Here one negative charge and here one positive charge. Let me draw. Q1 is negative and Q2 is positive. Already this is understood, Q2 is a bigger value. So we cannot get 0 near the bigger one. Clear? So somewhere here or somewhere here we cannot get. We can get somewhere here or somewhere here because 0 possible always near the smaller one. Whether here or here it requires calculation. If you consider any 1 coulomb say here, this minus Q1 will attract and this Q2 will repel. Clear? So because of that they are in the same side, so you cannot get 0 field here. You have to get the position of 0 field. So you will get position of 0 field somewhere here at this point. If you consider any 1 coulomb, minus Q1 will attract and this Q2 will repel. They are in the opposite direction. Q1 gives you lesser field, Q2 gives you greater field, but distance is large. Ultimately they cancel each other to get 0 field. So where you get 0 field? 0 field possible only in the region 1. So this kind of question is possible, and how to use the concept, I hope no difficulty. Few other points with electric field lines I want to discuss. Say someone interested in drawing uniform electric field. What is uniform electric field? Say if you draw electric field lines like this. Say in a region this kind of electric field line drawn. So if you find density here or density here or density here or density here, it appears same. So everywhere same density and direction of the field also same. So this is uniform electric field. Clear? By chance someone drawing electric field lines like this. So someone drawing electric field lines like this. I am considering a point here, say having field E1. I am considering a point here having field E2. So density in E1 more, density in E2 less. So in magnitude E2 less than E1. Clear? By chance you draw electric field lines like this, then also same. Here greater density, here lesser density. So if you consider this point say E1, this point say E2, here also E1 greater because greater density. So E2 is less than E1. Clear? So how to draw electric field lines, that is discussed. How to identify the position of zero electric field, identify zero electric field meaning zero electric force also. And at last we discuss what is electric field lines, how to draw uniform electric field lines. Okay. Now I am coming with a new class after that, how to use this concept of electric field lines. Okay, this is over.